Hello everyone, welcome to my programming club. Today we will be solving another daily lead code challenge, and the challenge name is word break. So the challenge statement is like this: given a string S and a dictionary of strings word dictionary, you have to return true if that word can be segmented into a space separated sequence of one or more dictionary words. So what the problem statement is saying. So let me explain by taking this simple input. Now this is the sample input. So this is the given word dictionary and the string. So what you have to do is you have to check if this word can be segmented into segments which are nothing but the words in segments are in words in the dictionary. So here we can segment it in this way, and these two words or segments formed, these two segments are present as words in this dictionary. So we have to return true if this is possible, otherwise we have to return false. So if we can segment the given word as given string as in such a way that each of the words in the segments is a word in the dictionary, then we will return true, otherwise we will return false. So this is what the problem statement is asking us. Now let's move to the constraints part of the problem. What are the constraints? So the length of the thing is given of order 300. Thing's length will be of order 300, and dictionary length is given to be 1000. So this word dictionary is given to be 1000. Word length is given to be 20. So it will not be a issue of major concern for us since they are pretty small. So all the strings in the word dictionary are unique. So there is no repetition in this dictionary. So what will be a brute force way to solve this problem? What will be the brute force way? First way to solve the problem is, let me quickly clear out the words. A brute force way would be to generate all the possible partitions. So what we will be doing, let's say if we are iterating over the string, then at a particular index, we will have a choice. Let's mark these indices 1, 2, 3, 4, 5, 6, 7. Then at this index, let's say we are at 0th index, then at this index, we are having a choice whether we can make a partition here and separate these two, or we can ignore making a partition for this index, and we will move to another index. And for this index also we have a choice that we can make a partition here, or we can move to another index. So what each index is having, each index is having two choices. For each index there are two choices. either to make a partition here, make a partition, not make a, not to make a partition. These two choices are for available for every index. So if the length of the string is n, then there will be 2 raised to power n choices. And string's length, as mentioned in the constraints, is of order 300. So 2 raised to power 300, it will be the number of operations that will be required to reach an answer in worst case. So our time complexity will be O 2 raised to power n is the size of the string. So it is very much higher than 2 raised to power 300 is greater than 10 raised to power 8 operations allowed in 1 second. For those of you who are not familiar with what I am talking about here, uh, if you are not having idea how the time complexity of accepted solution varies according to input size, then I will provide a link of article describing this. You can check that article and then you will be able to understand what I am saying here. Basically, right now I can tell you is in 1 second there are 10 raised to 8 power operations allowed, and if your program does operations greater than or equal to 10 raised to power 8, then you may get a TLE, time limit exceeded, and your solution will not be accepted. So you have to optimize this brute force way. So you have to do optimizations. For brute force, you have to do optimizations. Now you may ask how we will be doing optimizations. Now in if you observe, let me clear the board. Uh, yeah, it's clear now. We are optimizing over the brute force. So yeah. So if you, let's say you are at this index, if you know that are there any previous, are there any previous indices, till where the partitioning done was a valid one. So for each index you will be checking before indices before that index, are there any previous indices till where the partitioning done was a valid one. What I am saying is, for example, let's say when you keep on checking, you reached uh, this index. Uh, yeah, this index you have reached, and the result till here was stored in the index number 3. Let's say we were storing the result, And for since for index number 3, it is a valid one. Lead is present in the word dictionary, so it will be true that partitioning is correct till here. If this were the only word that will be given to you, then this will be correct. Partitioning done is correct till here. So if partitioning done is correct till here and 3 is storing the result which is true, result of 3 is true, and press all the values in this results array. Let's say array is of the same size of this string which is 7. Rest all the values are false. Rest all are false. And this 3 is true. This is false. This is false. This is false. And this is true. And you are currently at this index and you are checking backwards. So if you found a index where partitioning is valid, this was the index where the partitioning was valid, where the till where the partitioning done was a valid one. Since this letter is present, this word is present in the dictionary. So what you will do is, instead of repeating the calculation for the previous ones and checking if there are also a valid partition, you will simply tell that till here, till the third index, there is a valid partitions. Then you will check if the word formed between. Let me quickly erase the board. Then what you will check, if let's say you encountered true here, the partitioning till here was correct, and you are at let's say this index, this fourth index, current index is this. You are currently here, and you are checking. So you know that till here it's correct. It's not a concern of yours. So it's already been taken care of, and the partitioning till here it's correct till the third index. So you will check whether this word formed from your current to your, if you let's say decide to make a partition here only at C, you will see is this word present in the dictionary. No, it's not present in the dictionary. So you will, what you will do, you will increase your current index. You will move to a new index. So what you will do, you will increase the current. So instead of making a partition here, you will simply increase the current and you will come here. Then you will check whether CO is present in dictionary. No, it's not present. Then again you will move the current, and till now you till then you will find the match. You will continue moving your current pointer, and at last when you will be at this index, you will be having a word code, and at till 3 index it will be third index it will be fine. Partitioning is valid. So you have also formed a word who which is present in the dictionary. So what you will do, you will mark this index true. So what true represents that till this index, if partitioning is done, there is a way that will make that partitioning valid one. So there will be number of ways you can make a partition here or here, but there exists at least one way which will make a valid partition. So uh, true at this index will represent that till this index, if the partitioning is done, there exists at least one way. There is at least one way that makes the partition valid. So at least one way is existing that will make the partition valid till that index. So you will mark this as true. And if let's say Leetcode is further extending, let's say it's GFG also. Now you know that till this index it's true, and till t the third index also it's true, but you don't know about the further indices. Now what you will do is, this is already taken care of. You will try to form substrings here and check for all of them. You will first check for G, it's not present in the dictionary. You will check for GF, it's not present. You will check for GFG, it's not present in the dictionary. So at last, your final index, your last index will denote whether till this index, if partitioning is done, there exists at least one way that make the partitioning valid. Since there is not existing a way, you will return false. So the overall answer for this string lead code will be true. And if the string happens to be lead code and GFG, it will be false. And where will this result be stored? At the results array and at the index of the last index of the string. So uh, this is the logic, and this will save us from extra calculations. Basically, we will not be doing calculations for each index again and again, because if you consider that those 2 raised to power n choices, it will happen. Let's say uh, first of all you make a partition at the 0th index, and then you decided to make the partition at first index, and then you make to decide the partition at the third index. It may happen that in this is a set of choice. Let's call this set 1, first choice, first set of choices. Then it may happen that you skip that 0 and you just decide to make partition over over this index only after the first index, and you will again encounter the choice for the third index and you decide to make a partition here. Now these two choices are overlapping in these two different choices, set of choices, and these two are overlapping, and you will do extra work here. Also, it is to be noted that if you know the answer of the previous indices visited, whether it will lead to a safe state or not, whether the string till that index will lead to a safe state or not, you can form the answer for the next indices. Next indices. So what we are doing here essentially is, you can divide the problem into subproblems. This is the big problem, and these are the subproblems. So it is to be observed that the results of these subproblems can be combined to, let's say these are the solution, so these are the subproblems 1, 2 and 3, and their solutions are solution 3, solution 2 Let me quickly change the color also. Uh, Solution 2, and this is solution 1. So after combining solution 1, 2 and 3, you will get solution for the bigger problem, which is, let's say, call this solution B. So this is nothing but optimal substructure in which a problem can be divided. Optimal substructure. Pardon me if some spelling is incorrect. I hope it does not affect your learning. So if some problem can be divided into a set of sub-problems, and solution for those sub-problems can be combined to form the problem of to form the solution of the actual bigger problem, then this satisfies the condition for the optimal substructure. And also there is overlapping sub-problems. Those of you who are new to these conditions of overlapping subproblems and optimal substructure, I will provide a link for them also. Then you can uh, explore these articles, and you will be able to understand what we are doing. So what essentially we are doing here is we are applying dynamic programming. Dynamic programming is nothing but optimization over brute force, in which you store your result. Uh, we were storing the result in the results variable for all the indices. So that you do not have to do extra work. Do not have to do extra work. Where you will have to do extra work? When you will be having overlapping subproblems in different set of choices. These two are different set of choices, but these two are having same subproblems, and same calculation will be repeated. So to avoid this overlapping subproblem, extra work done for overlapping subproblem, you will do you will what you will do, you will store your results. When you will encounter this problem subproblem for the first time, you will store it and you will use that result. So this is what dynamic programming is. So let's move to the coding part. There you will be able to understand the solution in a much clearer way. So yeah, so what we have done here is this size is of no use. uh, we have essentially stored the size of the string, and we have called this SSZ. And what we have done is, since the dictionary is having all the words in the dictionary are unique, so for quick lookup, lookup in dictionary in approximately O of 1, we are using a set, storing the words of the dictionary in a set. So then what we are doing is we have made a vector save state. This is nothing for storing results for the overlapping subproblems, and also building bigger solution solution to bigger problem based on the solution to the smaller ones. So this is the use of this save state array. What it's representing is, for a length L, for a substring of S of length say L, is uh, is it a valid partition? Is a valid partition existing is at least, basically at least one valid partition should exist, is at least one valid partition existing. For a substring of S of length L is at least one valid partition existing. This shape state will denote that. So these are the lengths of the substring of S. These are the lengths of the substrings of S. So what we are doing here is, for each length of the length possible for the substrings of S, we are checking, we are going from right to left to check for a index where a safe state exists. So if we found that index, we will not check for the further indices and not be checking for the further indices, and we will simply break, because we need not to do any work beyond this. If we found a safe state, if safe state found, then we need not to do any work. Basically there are two conditions satisfying if safe state is found also, and also the substring being formed from length from left to left plus length minus left minus 1 then is found from that substring that will be found from these two indices, left to length, left plus length minus 1 plus left. What I am talking about here is, let's say, let me quickly show this how we are iterating over this. Now let's say, let's take the example of that Leetcode itself, which was Leetcode. Now let's say you are here and this is true, and currently your length is pointing to here. Length is basically pointing to here. Length is 3, 4, 5, 6 and 7. So the length of the string is 8. So your left is currently pointing to here. The substring between this length minus 1 and left, we will check for this substring. If this substring is in the dictionary, this substring happens to be in this dictionary from left to length minus 1, then you will mark this length true. So I have already explained what true at a particular length denotes. Actually, we are checking is there is at least one valid partition for till this length. So I hope it's clear to you. So if that is the case, then you will simply return, and you do not have to do any uh, further work. So you do not have to check for further safe states. If you found a single safe state and then the substring between the length and the left index is uh, is present in this word dictionary, then you will return true. Last word will be the where will be the result stored. It will be stored at the length of the string, which is nothing but SSZ. So at last you will be returning it. So that's pretty much it. So thank you for watching. If you have any doubts, feel free to ask them in the comment section. Thanks.